Hi everyone. In the last couple of videos, we talked about chiral, achiral, and achiral meso molecules. We kind of established some parameters that would ultimately describe their structure and how we thought about them, okay? In this video, we're going to be doing an overview on how to determine if a molecule is chiral, achiral meso, or achiral not meso. Now, we're going to start off by saying that if asymmetric centers are present in a molecule, I want you to start to lean towards chiral. We're always going to problem solve though. If, however, you look at a molecule, let's look at these ones down here, and you see that there are asymmetric centers, but that there's this constitutional line of symmetry. And if it's a ring structure, it's about the ring, okay? Line of symmetry is about the ring. If you see that constitutional line of symmetry, I want you to check for R-S configurations. If you have asymmetric centers, but opposite R and S configurations about that constitutional line of symmetry, you have a meso compound, and meso compounds are achiral. Their mirror image is superimposable. Achiral molecules have superimposable mirror images. The thing with meso compounds that's a little goofy is they have asymmetric centers, but there is achirality to the molecule. They do not rotate plane polarized light. So if that constitutional line of symmetry exists and we have RS configurations, that means there's a mirror plane that exists. Meso compounds could have some multiple of two asymmetric centers, but about that line of constitutional symmetry at the respective chiral carbons, you would have complementary R and S configurations. Okay, there is no optical activity for a meso compound, which is an achiral compound. All right. Now, let's say we take this far left compound and alter its structure a little bit. We're going to make one of the chlorines dash wedge and keep the other one solid wedge. Okay. We're now going to talk about determining if something is chiral. We said if there's asymmetric centers, we lean towards chiral. We look for any type of constitutional plane. We see that here. So we're thinking maybe meso, yes, no. Let's problem solve always, right? Especially if it's a straight chain, especially if it's a straight chain. Here we have SS configurations. So if that constitutional line of symmetry is present and we get RRSS configurations, that's just chiral, right? Asymmetric centers present, constitutional line of symmetry, but RR or SS, that's a chiral molecule. If you had that line of symmetry and RS configurations, then it would be achiral meso. So quite simply, chiral molecules are molecules that could possess asymmetric centers that are not meso. A chiral molecule is a molecule with a non-superimposable mirror image, right? And usually having these asymmetric centers confers that non-superimposability of the mirror image. The one funky case where that doesn't work, right, is our case of meso compounds, where yes, there are asymmetric centers, but the mirror image is superimposable. If a molecule had an odd number of asymmetric centers, pretty much a guarantee it's chiral, okay? If there is no plane of symmetry, constitutional symmetry, that means there cannot be any type of mirror plane, and those mirror planes specifically are the constitutional plane of symmetry with opposing RS configurations. If there is no line of symmetry, right, in this molecule, there is no line of symmetry because we have different groups on either side definitively. If we have asymmetric centers and no mirror plane exists, well, that's just chiral, okay? So with asymmetric centers, we're leaning towards chiral, but we'll check for any constitutional plane of symmetry and RS configurations. If that were present, our bell in our brain should go ding, ding, ding. That is a meso compound. Now let's talk about what if asymmetric centers are not present. If there are no asymmetric centers, it's pretty safe to lean towards achiral, not meso. There are some exceptions here, which we'll talk about in subsequent videos, called atrope isomers, which lack asymmetric centers, but are still chiral as a result of non-superimposability of its mirror image being conferred by this hindered rotation about carbon-carbon bonds. So yes, there are molecules that lack asymmetric centers that can be chiral. We'll talk about identifying those. So think about that kind of being an exception. We'll talk about that later for your purposes now. With the exception of those exceptions, if a molecule is lacking asymmetric centers, I want you to think it is going to be achiral, not meso. Now, achiral not meso is different from achiral meso because achiral meso compounds possess asymmetric centers. A molecule that is achiral not meso would not possess asymmetric centers. Okay. In the next video, we are going to be going over examples of problem solving, and I'm going to illustrate these rules for you in different visual contexts.